So that's a little bit of background on Cambridge Clean Tech and what we're doing at the moment. I'm just going to hand over now to Peter Bates, who's our sort of co-host and organizer of these event series on smart homes, to say a few words. Over to you, Peter. Peter, you need to unmute yourself, Peter, please.
Yes, thank you. It would certainly help. You missed what I actually said then, Martin, but not to worry.
We all missed it.
Okay, welcome everybody to the second event of the smart homes. I'll get it right in a moment too. The Sustainable Smart Homes Special Interest Group. We've hopefully were very successful about a month ago when we ran an event on the Green Homes Grant and the implications of retrofitting your home. And now we're moving on to looking at how can we decarbonise the home. I'm going to ask Ariane to move to the next slide, please. Just a quick kind of recap on what the Special Interest Group is all about. We're looking at being sustainability. We're looking at how can we actually meet the targets of the 2050 targets for carbon zero, particularly focused around homes. And we've got something like 27 million homes that are going to require a lot of work to be done before 2050 to get them up to the appropriate standard. But equally so, we're also looking at innovations which actually can make those improvements to the homes for the market of something like 27 million homes, but then potentially in other parts of the world as well. Next, please. I think there's a little bit of a gap between me saying next and Ariane being able to bring the next one up. Sorry, I didn't mean next just then. If I can actually also highlight something which we set up since the last meeting, which is the LinkedIn group. So we actually have a LinkedIn group, which is also called Sustainable Smart Homes. If you just do a search on Sustainable Smart Homes, it will actually appear if you are a member of LinkedIn in that respect. And the idea of this LinkedIn group is to share ideas and best practice across the world, and also bring in innovative kind of ideas from other parts of the world in that respect. Okay, next please. Next, Ariane. Okay, so we have a really big issue as far as homes are concerned, because we've only got something like 5% of homes are currently have low carbon heating, and really heating is the big issue that needs to be dealt with as far as homes are concerned. Next. And I think the issue is we can't really take a blanket approach or a top-down approach to the solutions. I mean, currently everybody's talking about, the solutions might be air source heat pumps or ground source heat pumps. This is something I have been seriously looking at for my own house, and I'll talk more about my house a bit later in a moment too. But I think we also need to have a bottom-up approach and choose what are the best low carbon heating solutions, because every house is unique. And that was adapted from Catapult Energy Systems in a document they wrote in March this year. Next, Ariane, please. Next, please. Okay, so what I'm going to look at to begin with is where I'm going with my own house. It's a simple 3-bedroom, semi-detached house built around about 1975. Next, please. I've tried to take a fabric first approach or as a start off for whole house to insulation by looking at insulation first. I've attempted to look at loft insulation. I've attempted to look at cavity wall insulation. That big red arrow is pointing to a borehole which if you've got a property of around about 1960s, 70s, 80s, and it's of a cavity wall build, you are likely to have had cavity wall insulation put in, and that's the indicator of those boreholes we've got there. Next. So what do I have currently? I have a 30-year-old gas boiler, mains gas boiler. I have a room thermostat, which is in the hall. It seems to me that most mains gas installers actually put those in the hall, which is probably not the most efficient place to put them, particularly when you actually have a front door which will probably open and close in that respect. Fortunately, there are now remote solutions available, which you can probably put, or better to put them into the living room hall. And obviously I've got radiators, wet system with the thermostat. You can see it on the bottom right picture, and the thermostat on the right at the bottom as well. So my roadmap. Next, Ariane. I probably didn't take a whole house approach and a fabric first approach at the time of 18 years ago. I was probably conned into, to a certain extent, in getting solar thermal, but I was concerned about reducing my carbon emissions. And on the top of that roof, you can see the solar thermal on the bottom and slightly to the right. We'll come to that later, but the top are the solar thermal panels. And you've got the bits inside the roof on the picture to the top. And I had to also get a replacement boiler at the time. Now that is probably providing me with something like, for 5 to 6 months of the year, free hot water from the solar thermal. Occasionally I do have to top it up with what is currently my gas central heating boiler. Next. But then I decided that in 2011 and 2012, I would actually have solar PV put in. Surprise, you get a free ticket to the next event, by the way, if anybody can tell me, except Nicola, that the reason why I had to have 2 solar PV arrays put in. One is actually on the roof. And if you look on the picture on the top right-hand side, those are the panels on the flat garage roof as well. And those are the 2 inverters on the bottom picture, which I had installed. Next. And then I decided to probably experiment, because it's still very expensive to put in battery storage system. And I really didn't know at the time how large a system I really wanted to put in. What I did know is I wanted to be able to cook or get my wife to cook at peak times between 4 and 7 o'clock in the evening time without her having to change her habits. So I decided to go for a 15 kilowatt system. You can see on the left-hand side there. And I decided that I wanted to be able to import and export at 5 kilowatts. And I reckon that 5 kilowatts into the home, if I had my kettle on and I had my electric cooker on and possibly my microwave, I might just have enough to cover without having to bring more in from the grid at that time. So that's one reason why I decided to do that. Next one. I also decided to go for Octopus's flexible tariffs. So I'm using Octopus's agile tariff. You can see on the left-hand side, not very clearly, I'm afraid, but the prices of the electricity vary every half hour. So it means that I can actually control when my battery storage system is actually importing from the grid. And I can also, because I'm using Octopus Energy's outgoing tariff, I can also decide when I want to export back to the grid. Next one. And this is a graph which actually gives you an idea of what the rates are for the agile rates. These are the flexible half-hour rates incoming electricity. And you can see round about this time, 4 o'clock through to 7 o'clock, those are the peak rates, which I'm trying to avoid. You can see that in the early morning, the prices are actually a lot lower. So what I'm trying to do is to buy the electricity when it's cheap, store it, and then sell it back to the grid. If we look at the next slide. Utilising the outgoing rates. And you can see that we gain between 4 and 7 o'clock in the evening time. That's the time when I'm actually trying to sell back to the grid at a much higher rate than I actually would have paid for it by storing it. Now, there's obviously going to be a certain amount of loss of electricity by going through that process, but I'm still experimenting. I've nearly come up to 12 months and I'll have a much better idea of how much I've actually made. In fact, Nicola, who will be speaking later, has been looking at some of my figures and will come back with some conclusions as to how much I've saved or not later on in this event. Can I also say that we are going to be talking a lot about Octopus Energy, because probably at this moment in time, they are the most innovative utility company in terms of providing electricity to people. There are other companies who will be coming along and offering more of a flexible rate. I know Octopus themselves have actually sold or at least white labelled their system to Good Energy, who were one of the pioneers. At least they are offering 3 different rates, and also E.ON, who were offering, who will soon offer rates. And I understand, listening to a webinar earlier today, that Over Energy will at some stage next year offer flexible rates as well. But certainly, Octopus Energy are the pioneers in this respect, and Phil Steele will be speaking about this in a moment or two. Next one.
Coming up to time, Peter. Just to
okay,
let you know.
Thanks. Yeah, I'm experimenting still. I'm actually experimenting with intelligent electric heating. I'm experimenting with the smart plugs. These are actually really great. They take about 2 minutes to set up, utilising Bluetooth, and then they're connected up via Wi-Fi. And what I've actually done is that bottom right-hand picture is underneath my desk where I'm currently sitting now, and I have a 15 kilowatt electric heater. The wires are all connected to the computer system. Perhaps not put in the most safe way, but that is only a 15 kilowatt system. And I can control it with this, utilising the smart plug and the app on my phone. Next one. And what I want to do in the future is I want to get an electric car. I want to get a 62 kilowatt battery system, and I want to use that as a second battery storage system. But I'm still waiting for vehicle to grid charging to be publicly available. There's a lot of trials going on currently, but in fact, I can't seem to get hold of a vehicle to grid charger right at the moment in time. Our next event in December, which I'll talk more about later, will actually focus more about this one. And the next one, Ariane, yes, please, last one. So sorry, next, back again. Okay, what I want to really, just to summarise, what are really needed, it's the challenge to industry. I currently don't have a home energy management system where I can control everything. I have to manually, either use a smart plug to switch on my immersion heater when I don't have enough hot water in order to, because I haven't had enough solar energy to generate enough hot water for the day. So I'm manually doing that. I'm having to kind of switch on and off this electric heater underneath my desk at the present moment. I have to, most irritatingly, what I have to do is, if I want to get the most efficient kind of prices for importing electricity from Octopus and then exporting it back to Octopus, I have to do that manually every day. Octopus make available those tariffs about 4 o'clock in the evening onwards. I then have to, using a third-party website, put it into a spreadsheet, go through, select every half hour, and then put it into my smartphone using another app to control my smart meter. So that's certainly one thing I do. Also, flexible tariffs. Yes, we're talking about those. Flexible heating systems. I think we're looking for flexible modular heating systems, because not every house is unique. And we need to have a whole variety of different solutions if we're going to decarbonise the home and utilise electricity. And there's a few more things which I won't say anything more about now, because I want to now move on and introduce, or for Phil himself, Phil Steele, who is the Future Technologies Evangelist from Octopus Energy, and he's going to talk about Octopus.
Great, thanks, Peter. I'm just trying to find my slides so I can share them. And the moment I went to do share, it lost my slides. Give me a second. Right. Share. There we go. Okay, can you see my slides?
Yes, Phil, yeah.
Okay, good, thank you. So, let's be able to go back. There we go, okay. I have a really fancy title, Future Technologies Evangelist. I should explain that because it's on my LinkedIn profile, and so often people introduce me as having the most interesting, exciting title in the industry. I joined Octopus about 2.5 years ago. Greg Jackson, CEO founder, acquired my smart home business. And Greg quickly gave me this title because he wanted me to head up what is effectively innovation, research and development projects all across Octopus. So that's kind of spanning everything from our Power Loop project, which is vehicle to grid that you mentioned briefly, Peter, research projects when it comes to like Energy Local, the Ripple project, which Sarah's going to talk about later on as well, and a whole load of other things that we're doing. And I'm going to cover a lot of that in here. I also am responsible for the Agile tariff, the Go tariff, the Tesla tariff that we have, and launched our export services April 2019 too. And I'm going to talk about a lot of that as I go through this. Very brief history of Octopus. It's a short history. 2016 we launched, winning a lot of awards. We're accelerating on the number of customers that we have, 1.5 million retail customers in the UK, but the platform is licensed to other energy suppliers, as Peter mentioned, Good Energy and E.ON, Origin in Australia. We acquired a business in America recently as well. So we're probably way past 6 million now on the platform that's licensed. The group is made up of several businesses, actually. So there's Octopus Energy, which is the retail business. That's what most of us know about Octopus. Octopus Electric Vehicles, so we lease and sell electric vehicles, including the V2G under the Power Loop project. We have our own business solutions team as well, so we supply businesses with energy too. Far right-hand side there is Octopus Energy Services. So we are our own map, and we install smart meters now, and you'll start to see a lot of Octopus Energy vans around the streets, installing meters. Underpinning Octopus is Kraken. So Kraken it started off as our internal name for the IT platform we created, and it's now kind of publicly known and referred to as the Kraken platform. And that's our own technology built from the ground up that does all of the billing, all the meter data collection, all the statement production, and all of the customer care and operations. And it's that platform that has been licensed to the other brands that are in the bottom corner there. And then we also have partnerships with M&S Energy, Tesla, Co-op Energy that we support as well. Monzo is a partnership there. There's a whole load more there. And 400 is a business in Germany that we acquired too. So we're in Australia, Germany, UK and America already in the space of 4 years. As I mentioned, we win quite a lot of awards. We're the only which recommended supplier and have been for 3 years now. Customer service is really important to us. So we provide customers with a phone number to call us in, email support, Facebook, Twitter, and so on, all the social media. So achieving 5-star Trustpilot is really important for us and maintaining that level of customer response and support. So I mentioned there Kraken. What we are effectively is an energy tech business rather than just an energy supplier. So as the statement says here, we use technology to bring lower and more transparent pricing, better service and more sustainable energy to customers. I'm going to go through how some of the tariffs that we've launched have done that, and some of those research projects and things that we're involved in. So let's start off looking at it from a renewable point of view. We talk about being a 100% renewable energy supplier. But if you look at renewable energy on the grid, wind and solar, we can see on the graph on the left there that the level of renewable energy on the grid is now starting to overtake fossil fuel and nuclear generation. But the issue that causes is the level of intermittency. So the top graph on the right, so typical solar generation with our climate, sun and clouds and so on, you see solar output dramatically zipping up and down through the day. And then similarly with wind generation, you see a lot of spiky output of wind and then drops on very calm, quiet days. So those trends are interesting because it means the grid is becoming far more distributed in the supply of energy, more renewable, but so much more intermittent. And that means we can start to do clever things with the tariffs. Now, to do that depends on a smart meter. So smart meters are now rolling out at a fairly fast rate. It's been technically very challenging to get the meters in and working. And if you go to our blog, you'll discover all sorts of interesting stories that Greg has written about as to some of the issues we had with the early installs of version 2 of smart meters. So SMETS 2 are the meters that are connected through the Data Communications Company. So that's the government's central system and platform for managing smart meters. So the figures a couple of days ago, 5.6 million SMETS 2 meters installed now, and 1.7 million of SMETS 1s have been migrated across from legacy platforms that were specific to the manufacturer of those SMETS 1 meters, whether it's LNG or Clara or Secure, and are now enrolled in DCC and effectively acting as SMETS 2 meters. That's really important because if somebody has a SMETS 1 meter from another manufacturer, you may not be able to switch it to another energy supplier and for it to continue to be treated as a smart meter. So that DCC becomes quite central to managing smart meters and the tariffs that we've launched. So talking about those tariffs, the focus for us here is behavior change. How do we get people more engaged in renewable energy, green energy? And so through that intermittency I talked about and the rollout of the smart meters, that means we can do half-hourly billing, as Peter was showing on some of his slides. So some of the smart tariffs that we've launched are Agile Octopus, Octopus Go Faster, which is a version of Go that I'll talk about, and then also our export tariffs, so Outgoing Octopus, of which there's a flat rate version and an agile version for export as well. So I'm going to go through each of those in a bit of detail. So the Go tariff offers customers a cheap rate between midnight and 4:30 in the morning of 5 pence per kilowatt hour. So it's a bit like an Eco7 sort of a tariff model with an off-peak price and another price for the rest of the day, around about 14 or 15 pence. This tariff was originally designed and promoted towards electric vehicle drivers, although we don't enforce customers to be electric vehicle drivers in order to have that tariff. So we have other customers with just hot water systems and things that are using the Go tariff, or people like Peter with batteries that are charging the battery at that time of day. It's an easy tariff to adopt because you haven't got to look at the agile prices every day. On top of Go, we've got another set of tariffs called Go Faster. This was set up as a research project initially, because what we have seen is that as the numbers of customers on Go have increased, they may actually cause an artificial high demand at midnight when a large number of electric vehicle chargers, home battery storage systems and so on all start to try and consume energy during that time period. So Go Faster starts to try and smooth that out. And in fact, one of the things we experimented with was asking customers, would they prefer a Go Faster tariff that starts at 8:30, 9:30 or 10:30, and do they want a 3 or 4 or 5 hour version? But actually, because this is about smoothing, we identified some and said, actually, I'm afraid we can't give you that tariff, and this is the next one that's available for you, in kind of recognition that these tariffs were offered in order to try and balance the load on the grid and to soak up renewable energy as we have high winds overnight, as a nighttime tariff rate. And I'll show some of the results of that in a moment as well. Now, this is a Go tariff statement. It's one page from a customer statement. You can see the Go rate there in the pink curve drops down to 5 pence between midnight and 4:30, and you can see their energy consumption in the grey bars. I'm going to show more graphs about the other tariffs as well like this. One of the really interesting things here is this is a customer on Twitter sharing their energy statements. That's never happened before. I've never seen any other energy suppliers have customers sharing their energy bills in a positive way and shouting about how exciting these sorts of tariffs are. And there's more examples as I go through the presentation as well. So that's Go and Go Faster. Then we look at Agile. So Peter shared a screenshot of his rates on Agile. So I took a screenshot of the last couple of days. So you can see the rates, 27th, yeah, that was yesterday. So the rates yesterday were between, in fact, 6 to 7 pence in the early hours of the morning. As Peter said, the customer gets these rates at about 4 to 5 p.m. Every evening. And in fact, I'm refreshing mine just to see if they've come through yet. But we should see the rates for tomorrow come through. It hasn't quite been published yet, but I'll keep an eye on that and see what we've got. There's a larger view of the 26th. And you can see that there's a fairly significant variation. So at midnight there, the rate was 3.24 pence. And if I just go back to the previous screen, you can see it was 7.16. So the price of Agile actually does vary quite a bit from day to day. The general shape of the curve is fairly consistent. There is always a spike between 4 p.m. and 7 p.m. That is due to the way the algorithm that calculates Agile works. We add an extra 12 pence to the tariff at that time of day, because that's when we as an energy supplier have higher transport and distribution costs that we need to cover. On the wholesale market, the rates can go exceedingly high. So we actually cap that at 35 pence to avoid customers getting very penalised if the wholesale rates are way too high. But I mean, the upside is the advantage of these sorts of rates of 3, 4, 5 pence, such as we had on Monday and yesterday. More billing examples. So this is a customer with Agile incoming. You can see the pink line, same sort of shaped curve as the previous slides I just showed there. And the dark blue bar showing their consumption. So they've avoided any consumption during the peak period of 4 to 7. They've ended up with an average for the day of 5.66 pence per kilowatt hour. That's Agile import. Now let's look at Agile export. In the same way that the Agile tariff is calculated off the wholesale market, the export Agile version is also calculated off the wholesale market too. So if I look at the same customers, it's the same day as the previous graph. This is their export tariff, and they're on Agile. Now, I know that this customer actually has a battery storage system, and they're using solar. So their batteries supply most of their energy during the morning up to lunchtime, which is why there's a very flat level of consumption there. The battery has then been able to export a little bit in the early afternoon, which is the solar. So that's a curve down, and it's the solar exporting once the battery's full. And then the battery has started to export in the last peak of the 4 to 7 period. So as this is export, we've credited this customer with 6.85 pence per kilowatt hour, total rebate of 65 pence. So if I just go back to the previous slide, you'll notice here on the same day, they only imported 12 pence. So this customer ended up being better off as a result of what they consumed and what they generated and the excess that went out and got exported, which is really interesting to see. More examples of people sharing this on Twitter, people getting really excited about seeing their half-hour bills, the rates that they're getting, what they're going to do, putting on dishwasher, washing machine and so on, charging the mower up and whatever else that's going on. Loads of excitement. And if you go on Twitter, you'll find countless examples of customers sharing this, particularly over the weekend. I'm going to come to that in a moment, what happened on Sunday. I mentioned Go Faster and how we've designed that tariff to start to try and smooth out the demand on the grid. The black line in this graph is the set of customers, same set of customers here that were on the Go tariff, and you can see that the peak at 1 a.m. is the peak demand when all the Go customers were starting to charge cars. So when we offered them Go Faster and said, let's get you on to a 8.5 or half and start, and starts to try and balance out that demand. You can see in the blue graph on the far right hand side, the blue graph jumps up at 8:30 as those Go Faster customers all start to come on. And therefore, back over on the left at the 00:30 to about 2:30, you can see the blue graph is much lower than the black line, because we've managed to smooth out the use of energy compared to the Go tariff itself. So on that slide that I talked about the different tariffs and introduced them, I mentioned behavior change. That's what this is about, is encouraging customers to use renewable energy better through the power of tariffs rather than pure control of devices. Another interesting example, so middle of lockdown, May bank holidays this year, both May bank holidays were very, very windy days, the Sundays. And this is a headline on the Times that day, and the National Grid was actually looking to curtail wind generation because there was forecast to be way too much wind generation on the grid for the demand, the consumption that was required. I mean, that would have been extremely disappointing to start to have to curtail wind generation because of the level of generation. So we ran a research project effectively, and we invited customers to switch on when we had those windy periods on those 2 Sundays. So we did it as an incentive, and actually said, like the agile tariff when it goes negative, we said we will pay you to use electricity at certain hours of the day on those 2 Sundays. If you've got a smart meter and we can measure the data, irrespective of what tariff you're on. So we made that decision and published that invite. We published it to over 100,000 customers. We had about 50,000 customers that took part in the big switch on. We did it over 2 different time periods. So you can see here 5 a.m. to 7 a.m. on one of the Sundays and 2 p.m. till 4 p.m. on one of the Sundays. And you can see very clearly the huge spike in demand that we put onto the grid during those 2 hours. And this was with people being aware only 2 or 3 days in advance, because it's all dependent on weather forecasts and so on, that there was going to be this cheap period. And it's amazing just how many customers we actually had sign up to it. And something like 70 megawatts of electricity was consumed that wouldn't have been consumed otherwise during that. So again, behavior change and using renewable energy. Most customers actually only earned about 50p. It wasn't like a big money spinner to take part in this, but they were really engaged in doing something for using up renewable energy rather than seeing it being cut off. Some interesting stats. 8th of December 2018, this was actually the first time that we had a negative price on the tariff. As the agile import tariff is calculated from the wholesale market, the wholesale market does go negative when we have large amounts of renewable energy. So instead of paying a normal flat rate tariff of 15 pence or so on that date, it went negative, and it was one of the first times. So we sent out text messages to all customers on the agile tariff and said, you're going to get paid to use electricity tonight. And it dropped to minus 2.3 pence per kilowatt hour for some of the half hours on the 8th of December. So if I look at a customer's bill, and again, these are all on Twitter as well, you'll see them. You can see the pink line drops below 0 in the early hours of the morning. You can see it in the table below where it's 0 between 3:30 and about 5 a.m. And in the table, you can see the rate, the consumption, and therefore the cost. Now, this customer, I think this was actually our CTO testing the technology and charging his electric car at the time, because it was one of the first plunge pricing events we had. He charged his car during that peak, that plunge period, and did nothing else the rest of the day. So his average bill for the day has ended up at 2.29 pence per kilowatt hour, compared to a flat rate tariff of like 15 or 16 pence. Incredible. Now, for some quirk of nature, on the 8th of December 2019, so up here I was on the 8th of December 2018, precisely a year later, we had the next negative event, and we went down to minus 1.96 pence. And in fact, on the 9th of December, we hit a new low of minus 5.82 pence per kilowatt hour. So we had 2 negative days in a row with half hours that were below 0. 25th of October this year, so this was Sunday, extremely strong winds, and we actually hit minus 9.88 pence per kilowatt hour, which I think is the lowest negative rate that I've seen yet. And again, due to wind generation, massive wind generation on Sunday just gone.
Phil, just a couple more minutes, please. Sorry to interrupt.
Okay, sure. This is a screenshot actually of those rates on Sunday. So you can see here between that hit minus 9.88 at 1 a.m. to 1:30, and it was still negative through all of the night up until 5:30 a.m. During lockdown, actually, we've had quite a lot of negative occurrences because the level of demand on the grid has been quite a bit lower than normal. So there's a lot of examples of people having negative events. I'll speed up, Martin. Just want to cover a few other things on these couple of slides. So this is a customer on December 2019 that I mentioned. They actually end up with a negative day. So you can see at the bottom left there, their weighted average is minus 1.44 pence per kilowatt hour. So they've managed to actually get down below 0 for their agile consumption. This is still consumption that we're looking at here. Okay, one more fun example. 2nd of March 2018 was the Beast from the East, and we were covered in snow and ice, which meant huge amount of demand on the grid and not very much renewable generation. And so on the Agile Export Tariff, although the Agile Export Tariff wasn't live at the time, I ran the data backwards just to see what would happen on this particular day from the wholesale market. So the wholesale market was paying ridiculous amounts, or was costing a ridiculous amount of money for electricity because we all wanted electricity. Renewable wasn't generating. The fossil fuels and nuclear were at the maximum. So if your solar panels weren't covered in snow and ice, we would have paid an export rate of 36 pence per kilowatt hour for anybody that could export energy on that day. Of course, nobody could because we were all snowed under and solar panels weren't. And if you were generating it, you were probably consuming it as well. I know I've run out of time, but Peter mentioned an API. There's an API for that allows you to connect things up. One of the first things we did was with a service called If This Then That, which very quickly allows customers to connect those tariffs to all sorts of interesting things. So set my heating, activate a smart plug, play some music, put some money in a Monzo pot, whatever you can think of is connected to If to your energy bill. We also hooked it up to Amazon Alexa, so you can ask her how much is energy now, how much is going to be at a time, what's the cheapest time today, how much have I used. I won't set mine off because I haven't got time, but I have one here. And since then, a large number of developers, customers and partners have integrated to that API and connected all sorts of things. Take a note of that blog at the bottom. I mean, just generally Octopus Energy blog, there's a wealth of information that we publish there, but this one in particular talks about all these devices and systems that are connected. So last slide, Martin, to kind of summarize everything, tomorrow Octopus will bring energy from your neighbor's solar panels, share the energy and electric car with the homes on your street and automatically heat your water and price the cheapest. And that's all through the Cracker platform, what we do with smart meters and all the technology that you kind of see in this diagram here. And with that, I will pass over to Simon at Geo to talk about what his organization is doing inside the home as well. Simon.
Well, thank you very much, and thanks to Martin and Peter for setting this up. I mean, Phil, you've really set the scene here and outlined the opportunity for decarbonising homes through flexibility. What I and James Harrow, our VP of Hybrid Home Technologies from Geo, what we'd like to do in the next 20 minutes is build on that and give you a perspective from an energy technology provider and explain how those technologies that Phil, you showed in your last slide could come to life. So just a little bit about Geo, some context. We are based in Cambridge. We're a proud member, Martin, of Cambridge Clean Tech, and we were formed in 2006. So actually we're best known for in-home displays. 1 in every 2 in-home displays for the smart meter program in Great Britain are and will be made by Geo. And that gives us, that energy infrastructure that Phil's describing does give us a platform to use that sort of experience and apply it to this challenge of decarbonising homes and energy consumption in the home. In fact, if you take a look at our vision, and James will move us on to the next slide, what we're really trying to achieve is respond to that challenge, Phil, that you gave a few minutes ago. These tariffs enable a great opportunity to decarbonise and better match demand for energy with supply of energy. But you've mentioned several times this challenge of behaviour change. And we've set ourselves the challenge of using that technology, using the infrastructure that we have developed to become more energy efficient, helping homes to decarbonise and reduce their carbon footprint with some of that low cost, low carbon wind energy that Octopus and other tariffs will provide, but doing so without needing to change behaviour or without having to think about it. As Phil, you illustrated, if we were using and charging our EV at this point, it might be costing us 35p a kilowatt hour, whereas if we did it overnight, it will be costing us a lot less. So there are a series of technologies that are emerging, and Phil touched upon a number of them. and they're either in our homes or coming soon, from apps that we all have on our smartphones to smart heating controls. 15% of homes have smart heating. Smart charging with EVs. 80,000 homes will have an EV charger by the end of this year, a new one. Battery storage, Peter's got one of those. Solar panels, smart meters. About 40% of homes now have a smart meter, as Phil was touching on. But the opportunity here, which I'm going to hand over to James to describe, is how to use those, make best use of these new technologies to achieve that objective that we set out this afternoon to discuss, decarbonising our homes, but to do it in an efficient way. So over to James to talk about not just the technologies, some of the principles of demand side response and some of the dependencies that we're seeing. Over to you, James.
Thank you, Simon. Hope everyone can hear me okay. So today we're going to go through a little bit more detail about, as Peter mentioned earlier, that there are a couple of main drivers in the domestic space for helping to reduce our demand on CO2 and therefore fossil fuels. And those are really transport, so as Simon's mentioned, EVs, and heating. So whether or not you can replace your heat pump and hot water, assuming that you can sort your building fabric out as well. So as we move towards electrification of heating and transport, that puts new demands on the national grid. So yes, there's going to be more renewables as well, but also we're going to add a lot more load onto the grid, but actually also on substations. So this is an important factor that we'll come on to in more detail. I've talked about the more, Phil's given good examples of the more renewable generation causing these negative pricing events because there's more supply and sometimes there's less supply as well. So it's all about balancing the demand and the supply. The supply is getting more variable, the demand is going up, and we need techniques to do that. So there are a couple of things we'll talk about here. One is time of use tariffs, which we've talked about, but there's also a thing called demand side response, which may be maybe thought of as tariffs, but actually there's ways that the grid can actually send events to devices. And they can ask us to turn up or can turn down those devices automatically. And I'll talk a little bit what's happening in the standards to try and balance out the supply and the demand. So there's something called demand side response, or DSR. There's a lot of this going on already. You may be aware of grid scale batteries or commercial companies being asked to switch off their air conditioning. Those are all sorts of industrial and commercial opportunities that are being actively done as we speak. But there's a question of whether or not this will actually happen in the domestic setting, because you've got to think about, does a DSR operator really want to get engaged with millions of homeowners to do that? So there's a challenge there. Energy retailers will need to be part of that story. We're going to need technology to improve and reducing costs to make it viable. And we're going to need some support from government to help legislate and incentivize this market. We also need to really explain to users what is actually quite a complicated thing to explain. A number of people I've spoken to don't know the difference between a kilowatt hour, which is a unit of energy, and a kilowatt, which is a unit of power. They're sort of complicated. They're things that users possibly don't even need to worry about. Certainly before I had an EV a few years ago, I didn't really know the difference. Now I've got an EV, I'm very much engaged in that journey. And I think feedback has been that as people buy EVs, they'll become more understanding of these things. But we don't really want to load up consumers with that complexity. So we need to make it really smart and really simple. We're also thinking about if you suddenly are seeing lots of load on your smart meter, that might be alarming to you. So we need to think about how we change those user interfaces as well. There needs to be clear user benefits, and as Phil's already explained, there's demonstrations of that, how you might get cheaper energy or cashback or charge your car for a lower cost if you allow us to flex how you charge your car. And ultimately, users need to feel good that they're actually reducing their CO2 impact as well. And finally, the other quadrant is really standards and interoperability. Nobody wants to be locked into a proprietary solution, a proprietary vendor. They buy a very expensive battery storage system or solar or EV, and they can't switch to somebody else. So it's important for end users, but it also is important for the manufacturers to know that they're not doing something that's proprietary that no one else can switch to. So very briefly, I'm going to talk about the two types of demand side response. We've heard about how tariffs can affect users' behavior. So that's what we sort of call intrinsic DSR. And you can do clever things with battery storage that can capture your PV, use it later, help reduce your CO2. And then there's the explicit. This is where somebody on the national grid or someone at the, someone who's controlling the substations, etc., could actually send a signal to your property, to your EV charger or to your battery and say, actually, I'd like you to do something right now because the grid is under stress. I think there's a few, last year there was an event where one part of the UK's national grid went down. Lots of people were stranded at Liverpool Street in London, etc. They couldn't get anywhere. DSR could have helped with those sorts of things. On the right-hand side, very briefly, I'm just talking about something that's coming called PAS 1878. It's actually something that UK government is pushing as a standard, and they're funding the British Standards Institute to develop that. And it's called an energy smart appliance. How do we standardize how you can have interoperability between different energy smart appliances, i.e. your EV charger, your battery storage. It could even be a washing machine in the future. And how do you control that load from the cloud or from a cloud platform from a DSR service provider? And in the middle there, we're going to talk about the customer energy manager. And very UK specific is the smart metering. And how does that provide information to that customer energy manager, or what we call a SEM? Just briefly, Geo has been working with some trial partners. So EDF is an energy retailer we've been working with. Upside Energy is a DSR service provider that's working with us on this. And we've deployed 24 battery storage systems into public members in North East, in Sunderland, in Cambridgeshire, London and Sussex. Some of those have got PV, some of them have got EVs, and some of them have electric heating. And the main thing is to really understand how can we control all those assets without DSR? How can we do domestic DSR with grid signals, and how do we understand consumer engagement? But the output so far has been very successfully. We're seeing around about 55% on people's bills being saved because they're flexing when they charge their battery and when they use it, from the cheap rate and the expensive rate, and also how they can reduce the CO2 impact on the grid by not pulling in power when the grid is under stress, needing more power stations, etc. So I'm just going to quickly show you now a video. It's a couple of minutes long. It is a real live, it's not live now, but it is a real recording of an app that we've demonstrated with from this Core for Grid trial that's going. So hopefully you should be able to hear this as well. See if I can turn the volume down. And I'll talk over it ever so slightly. So I'm just sort of So this is our hybrid home solution that we're developing. As I say, it's got battery storage, electric heating, hot water, and also allows solar as well, and how we can integrate demand side response grid events from energy retailers, etc. You can see our smart meter there is actually connected to the display, is connected to the smart meter to get the tariffs, and then you can see what's happening, the power flows around the home from the different property appliances, and also the different energy sources, how the house is actually used as energy, where the solar generation has come from, and then also a part of our solution, we have an integrated heating control as well, smart thermostats. So you're just about to see a DSR event happening here on this. So the DSR's become active now, and we can see that the heating is using the power, but also the battery is taking some excess and charging at the same time. So it's all been carefully balanced by the home energy management system. So just, I'm not going to go through this slide in too much detail, but this is how things are actually working. It sort of works in 3 levels. One is understanding your usage, predicting how much you're going to use, how much your PV is going to generate. So that's like the optimization. And then the control layer is really working in, not in terms of energy, but it's working in terms of power. So as you turn on an appliance, it controls your battery to automatically discharge. Now you can buy off the shelf already battery storage systems which do that. They look at the grid meter and they say, oh, there's some import needed, so I'll discharge them to balance that out. But what we're showing here is actually, if you have the example of an EV that is switched on and you've got a battery storage system that's also working, those 2 things are not talking to each other. And what you'll find if you have a battery and an EV is that the battery doesn't know there's an EV there, and it starts to discharge all that storage and all that energy into your EV, which is inefficient. You probably find that your battery storage won't actually be able to provide the 7 kilowatts to your EV as it needs it. And also it means your home battery then goes flat and it's not available when you've got that big 4 to 7 PM peak load later in the day. So that's where the intelligence and the conversation between the EV charger and the battery needs to be controlled by something else. And we call that whole home energy optimization. And finally, it allows you to do the additional DSR events to the grid and also inform the user via the app. So just as a quick graphic here, these are the 24 homes you can see. We've actually got in the bottom right picture 4 properties in a row in one of the housing associations. And each of those properties is having its own energy usage and needs self-optimized. You can see the animation there, it's actually updating throughout the day, keeping track of the actual changes. So the prediction may have changed during the day, and it's also tracking the pricing. So you can see the tariff here is a 2-tier tariff, but we've also run this with the Agile Octopus tariff to see it react in different ways. So just almost wrapping up. So let's go through that same quadrants again. So do we see signs of change? Yes, I think we certainly see there's a need for domestic. One of the things we've seen is as a University of Sussex paper which says, you know, if you put 30 EVs on a housing estate with a substation, that is pretty likely to be overloaded. And you can't solve these issues by doing it at the grid scale batteries because it's not in the right part of the network. It needs to actually be done at the domestic level. And one of the things that I've mentioned, this PAS 1878 that the government are proposing, we've heard of July this year that they actually intend to legislate that all EV chargers, domestic EV chargers, will need to comply to that standard in the future. So that's a real Kickstarter, game-changing Kickstarter for domestic DSR, and hopefully the DSR community will get to grips with that very shortly. Again, good user experience. It's an area of the PAS standardization that we're involved in actually making sure that users can switch and they have a good experience. There's lots of debate in those standards meetings about that. Again, Phil's already talked about the Octopus Agile and the big switch on. This is already starting to demonstrate to users how they can benefit from negative pricing and exporting as well. But we're also seeing generally post-COVID or during COVID now, but the EV market is really picking up, and you're hearing about 6 months waiting lists to buy a Nissan Leaf. People really want to go green, they want to do their bit, and probably need to thank Greta Thunberg for that as well. And as I say, the standards is coming, hopefully, and we'll see if industry does start wanting to adopt that. So just to sum up, really, there's sort of 3 levels of, and why we talked to Simon said earlier about we want all homeowners to be able to do this stuff without having to think about it. This is why you need a home energy management system. So number 1, it needs to co-optimize the whole home energy management. It's not just separate systems working independently, they have to work together. We need to be able to use the time of use tariffs to help encourage users to shift when they do that. They need a signal to do that. We can do that implicitly using time of use tariffs, and finally we can do it explicitly using DSR signals. It's not a done deal yet. We need a little bit more support to make this all happen, but we need to move this away from, we need standards to help move this away from innovations and early adopters. You know, it's great that people can use if they're this then that, but not everybody can do that. We need products that can do that for people. That's what Geo is here for, but we need a standard to make sure that other manufacturers also support that, and consumers then have the confidence to invest in that. As I say, the government are looking to incentivise this. That's always good. Hopefully incentivising rather than forcing. And finally, we think that it's really important that energy retailers need to drive this and step up, because these assets, these battery storage, solar, they are expensive things that not everybody can afford. Maybe there's a model where you can do energy as a service, where rather than just selling kilowatt hours, you're selling an asset and selling the servicing of that asset, and helping actually the whole of the UK demonstrate CO2 savings at scale. So that's my last slide. Thank you very much. I'll hand over to Nicola.
Hi everybody. I'm just going to try and share my screen. I've forgotten how to do it. Share screen. And sorry. Right. So Peter asked me to speak on this occasion because he's a friend and I'm a consultant doing stuff with energy. In fact, with my Cambridge Energy hat on, I am actually involved in the Core for Good project that James was talking about earlier on, slightly. So he asked me to speak specifically on this line. Can you really sell electricity at a higher price than buying it? Looking at, and he gave me access to his bills to see what he was doing. It hasn't been totally trivial, but I've done my best. Now you've already seen these graphs, but you might be interested to see. So this is showing that the blue line is the incoming prices during a typical day, and the orange line is the export prices. And I'm also showing you the algorithm which Octopus publicises, so how they decide what the prices are going to be. Of course, this could change. There are no guarantees about what this thing is going to do in the future, but at the moment there is a whopping peak time premium for incoming, and quite a significant peak time premium for outgoing as well. This is based on Peter's bills. Notice that tariffs for the day are announced the day before at about 4 PM normally. So you've got about 8 hours to decide how to program it for the next day. This again are charts from Peter's bills. You can see that he has charged up his battery at about 4 o'clock in the morning, and then he's using nothing during most of the rest of the day, especially during the peak period. And on the same day exporting, he has obviously filled up his battery with the PV a little bit before the peak time starts, but then he exports a little bit then because his battery's full, and then he exports later on during the peak time because that's when he gets the good price. Now, there's various ways you get money from this. You can simply buy when it's cheap and sell when it's expensive. So bear in mind that your batteries are not 100% efficient. You've only got something like 90% efficient. So that means that if you're buying to put into your battery at about 3.2p, which is what Peter achieved on average in April, 3.2p per kilowatt hour, it's effectively 3.6 because you've got a 10% loss. But you can export it at 9. So, I mean, simply buy it cheap, sell it expensive, gets quite a bit of cash. And compare that with, you know, normally you'd be, well, I put there as 18.8p because I thought that was the standard price for Octopus fixed tariff, but it does seem rather high to me, so maybe that's wrong. Of course, if you've got PV, again, you've still got the 90% efficiency issue, but if you have a standard tariff, you're likely to be getting about a 5.5-ish. Peter's on average, he achieved 9 during April, so that's not bad considerable improvement. Of course, that 9p is equivalent to 8.1p when you've allowed for the 90% efficiency, but it's still pretty good. Typical April day, this looks a bit complicated because it is a bit complicated. And poor Peter's been setting this up, programming it manually every day to program the battery as to what to do the next day, which is absolutely extraordinary. I wouldn't do it. So you've got your PV, you've got about 2 kilowatt hours that you've got as normal self-consumption. So it comes straight from the PV into the household demand, but you've got another about 7 kilowatt hours of the household demand. Now, for simplification, I'm just assuming here that you use the battery once during the day, but in practice, that's not true. You can sort of charge it up and use, you know, if you've got significant use during the day, then you've got multiple chances and you could use the battery effectively more than once each day. But he has worked out from the weather how much sunshine we're going to get, and he's decided he's going to set the battery to import a 5.5 kilowatt hours, which will go into the battery, and he thinks there'll still be enough room for the PV, and he got it wrong because there was a little bit extra and that has gone. So we've got 1 kilowatt hour going straight out to grid export. Well, you know, swings and roundabouts, you do get things a bit wrong. But nonetheless, we got 5.5 coming into the battery there from the grid. You've got 7 going out at export, and his export price, I can't read it because I've got things over it. His export price on average was 9p, that's right. So that was quite good. And there's some losses. So I reckon that on this day, he actually gained 49p. And if he hadn't had a battery, he would have lost 43p. So that's your profit for the day from having the battery and using the agile tariffs. Hang on. This graph is to show seasonal variation in agile import prices. So it isn't very seasonal. You would expect it to be highly weather dependent, and it is highly weather dependent, but it isn't obviously seasonal yet, and I think it will be more so when we have a higher proportion of renewable energy. But the key point here is that the red line, this is the import, so the red line is the mean price during the day, and the blue line is the cheap time, and you can see there's a big difference. So by using the battery, you can buy considerably cheaper. The export prices vary too, and they tend to be lower in sunny weather because everybody's got lots of PV. On average, Peter was achieving between about 9p and 12p on his export. So in conclusion, with battery storage and a time of use tariff, which is flexible like Octopus, you can adjust your energy import and export times to create profit. Obviously, having a battery allows you to increase self-consumption. You don't need to fix the time of use tariff for that. But you can also sell your PV power at a higher price by choosing when you sell it, and you can do straightforward arbitrage on the grid power. You do need a significant size battery, both in terms of the storage capacity. Peter's is 15 kilowatt hours. You really want at least your normal daily consumption if you can. And also in terms of the charge discharge power, Peter did mention that he wants to be able to do all his cooking at once and have it all come from battery without having to import any extra. So that's a power discharge and charge power constraint. Programming it manually is time consuming and error prone. Of course, it will never be perfect because we're not very good at making predictions about the future, but we can try. You could have envisage a smart energy system which would do it for you, or you could give an aggregator control over your battery and have them do it for you, and then they can additionally take supply services such as DSR to the distribution networks, as James was talking about. So there are different options there, and I think, you know, some households will prefer one and some households will prefer the other. And also bearing in mind that although Octopus's tariffs at the moment are very good and useful and profitable, that can change. You know, who knows what will happen in the future? There are no guarantees, guys. That is the end of my presentation, and I will now hand on to Sam Bosson from the Greater South East Energy Hub. Sam?
Sorry, I'm here, guys. I'm just loading up the presentation. Okay, 1 second. I'd been preparing. Sorry, 1 second. To show all windows, it's got to be there somewhere. Here we go. There you go. I have done this before. Okay, guys, I assume you can all see my screen okay. Thank you for inviting me today. My name's Sam Bosson. I'm one of the energy project managers for the Greater South East Energy Hub. There are 5 energy hubs across England, and I'm just going to quickly run through today sort of what we do, and you might be able to see if you can, if it's relevant to you. So the South East Energy Hub is made up of 11 local enterprise partnerships, that LEPs we call them, that are sort of business focused. We are actually contracted to Cambridgeshire and Peterborough Combined Authority at the moment, but we essentially serve the public sector in general, and our board is made up of representatives of the 11 LEPs. So we're kind of, the actual energy hubs came off the back of a project led that looked at energy strategies for regions, and we help provide capacity to deliver those. So yeah, just a quick summary of our sort of main sort of areas of work. We essentially support the public sector primarily to invest in energy projects, and that includes universities, NHS, local authorities are our main clients though. And as I say, we kind of deliver a project pipeline that aligns with the energy strategies for the region. So in my region is the local energy strategy. Each LEP has their own regional energy strategy that we work to. Just to come on to some of our sort of key projects, we are currently administering the £10 million Rural Community Energy Fund that offers sort of stage 1 grants of sort of £40,000 for feasibility studies, and stage 2 grants up to £100,000 for eligible organisations. That includes like parish councils, registered social landlords. It can be a 50-50 partnership with, say, a local authority or even a private partner, but it has to be led by an eligible organisation. So yeah, that's definitely something worth checking out. We're also next financial year administering the £300 million local authority delivery scheme. That's essentially part of the wider Green Homes grant project, which I'm sure you're all aware of. That's a sort of £2 billion initiative by the government to sort of kickstart the industry and obviously improve energy efficiency across the board. We're currently working directly with local authorities on a questionnaire about that, to sort of inform the scope of what the scheme's going to look like, because we're looking at an allocation basis rather than an application basis as the current scheme is. But that's all sort of in the pipeline. We also undertake a number of different research projects directly for BEIS. I should have mentioned we're 100% funded by the Department for Business, Energy and Industrial Strategy. One particular project of interest for me is a social housing technical assistance pilot that I'm sort of leading on. That's looking at pathways to EPCC by 2030 and net zero by 2050 through a sort of fabric first approach. We also have our sort of main body of work. We have a £478 million now project pipeline of different projects that we're working on across the board. Usually, our role varies from sort of critical friend to sort of part funder to, consultant. We take a different role on lots of different projects. So yeah, it's just a quick high level overview. We, as I say, mainly local authority clients looking at sort of commercial buildings, solar farms, some policy around garden towns and things like that, but that's sort of our sort of bread and butter work. Just to give you an example of a project that we're working on at the moment, quite an interesting one, which is going to lead to a lot of housing and future, net zero housing, hopefully, which was a super grid outside Biggleswade that we are sort of have been supporting. It's been led by Central Bedfordshire Council. They essentially won Housing Infrastructure Fund bid for a significant amount of infrastructure funding, and I've had to actually invest in a new substation at 132 kV level, straight off the national grid from 275 kV, and it's opened up a lot of major questions around funding, recovery, cost recovery for local authorities to allow them to invest in grid infrastructure. So it's been quite an interesting project, really, because obviously, as you might know, if you've worked in that sector, it's highly regulated, and you know, how those rules are interpreted can often sort of have a major effect on the viability of a project, but also at a more local level. For example, if you wanted to get you know, say solar panels on your school, you know, grid capacity is becoming more and more of an issue, and local authorities are actually taking more of an active role in investing in that. So that's something that we've been working on, and has been moving successfully actually at the moment, which is really good. And a sort of more of a bread and butter project would be a solar farm at Luton Airport, which, you know, has been stalled due to COVID for obvious reasons. But this is a sort of bread and butter project for us. It's a perfect sort of scenario. We have an off-taker with a significant that requires a significant load. You've got the land to deliver the project. It's, you know, a limited number of partners, so it's a great project that hopefully we'll be able to bring off the shelf once the current crisis is over. And yeah, if anybody wants to contact me about this project or any other sort of research project or anything like that, you know, we've got our details here, and these slides will be shared after the presentation. So thanks. Oh, and now I'll hand over to Sarah, is it? Okay, 1 second. Sorry.
Yeah, thanks. I'll just pop my slides up here. Yep.
While Sarah's just getting ready, perhaps I could just remind people, if you have any questions, do put them onto the chat. We've had a few questions coming in, and we'll answer those after Sarah's presentation. Thank you.
Fantastic. Yeah, so I'm Sarah Merrick. I'm founder and CEO of Ripple Energy. So I'm just going to give you a quick introduction to Ripple, essentially. So what we do is we respond to people's desire for energy choices with real impacts. People want to act on climate change, and they want their energy choices to actually make a difference. And the problem that they face at the moment is that some of the current solutions either don't deliver the level of impact that they want, or they're really expensive. So there's lots of green tariffs in the market, and that's fantastic. And there's rooftop solar, but green tariffs don't in and of themselves deliver the sort of impact in terms of new deployment of projects that lots of customers want. And rooftop solar can be very expensive. So we set up Ripple in order to enable people to basically part own wind farms and solar parks and have the low-cost clean electricity that it generates supplied to their homes and businesses. And for our first project, we are partnering with Octopus Energy and Co-op Energy. So they basically buy the electricity from the wind farm and supply it to the owners' homes. And so what Ripple doesn't, Ripple's function didn't really exist until we set up Ripple. So what we are, how we're describing ourselves is the UK's first clean energy ownership platform. And so basically what we do is we secure consented shovel-ready wind farms, and we then set up an ownership co-op. So the owners own the wind farm via a co-op, and then we market the project to customers, and we switch them to our electricity supply if needed, and then we manage the wind farm's construction and operation. And then, as I said, Octopus Energy or Co-op Energy basically supplies the electricity from the wind farm to the owners' homes. And so our very first wind farm is called Graig Vather. It'll be the UK's first ever large-scale wind farm to be owned by the consumers that it supplies, essentially. And it's a single 2.5 megawatt turbine. It's just northwest of Cardiff. As I said, we've got Octopus and Co-op as our supply partners for that project. And ownership is really flexible. So it starts from £250. If you're a typical home and you wanted all of your electricity to be supplied or covered by the wind farm, it would cost you just under £1,900, but you can pay that in 5 really easy instalments. And so, as I said, so we are greener than a green tariff because you are making these projects happen. So you're getting real additionality, and we are cheaper than rooftop solar. So we estimate this is for our pilot project, that customers save over the 25-year lifetime of the wind farm. We estimate they save around 25% on their electricity bill. The upfront cost is around 65% cheaper than for rooftop solar. They obviously save CO2, so it's the equivalent of planting 250 new trees, and there's genuine ownership. So they genuinely own via the co-op however many watts of the wind farm they want. And yeah, it's just really, really simple. We take care of everything for them, basically. And we also hope to work with business customers too. So businesses can reduce their CO2 and demonstrate the sustainability values to their customers. They also obviously get low and stable bills. It's also a really obvious, clear way to show that they're acting on climate change. So if you've got a net zero target, own a bit of a wind farm to supply your company's electricity, it's obviously working for you. And again, it's just super simple for customers. And we also want to help employees, companies enable their employees to become owners of the wind farm as well. So we can offer via an employee benefit where the employer, a bit like a sort of season ticket loan, the employer basically gives a 12-month loan to the employee that covers the upfront cost, and they just recover it from their via a salary sacrifice type scheme. Or the employer can also provide it as an employee gift. So, you know, as the world of corporate electricity the division between corporate electricity use and domestic electricity use is sort of blurring with people working from home. It can be a way for employers to show their employees they recognise, you know, their home electricity use is now part of the company's electricity use, and to help subsidise the cost of that. And then we're also looking to work with building developers and housing providers to see how we can enable Ripple to be a sort of potential alternative to some on-site renewables as well. But just by giving people access to large-scale projects, obviously the upfront capex side of that can be considerably cheaper than putting on-site renewables on buildings where perhaps it might not be the most appropriate place to put that. And then good to follow on from other presenters as well. So we'll also develop an app where our customers can see how much electricity their bit of the wind farm or solar park or whatever is generating in real time and compare that with their electricity use. So you want to do this in a really, you know, visually engaging way. And then we want to integrate smart technology so that you know, customers' consumption can start to reflect the output of the wind farm. So, for example, we've got an MOU with EV Energy, which is a smart EV charging bit of software, and SunAmp, which is a heat battery. So, for example, your SunAmp heat battery could charge when the output from the wind farm is high, and avoiding charging in periods when the output from the wind farm is low. This can, over time, we hope to create the concept in our customers' minds of an energy balance, and then this gives them a reason. And people from GEO were talking about it earlier. It gives people a reason to embrace smart home energy technology. So, you know, okay, you can save whatever a pound or so on your electricity bill, but actually, if we say to customers, we can enable you to make sure you're using electricity when your wind farm is operating at highest level, so that you're using as much of the electricity that your wind farm's generating as possible. That's a very different proposition, and it's a far more engaging and compelling proposition for customers. So we hope that by creating this link between consumption and generation, it can help unlock a lot of the benefits of smart energy technology by making it far more engaging for our customers. So yeah, we consider that Ripple is the smart way to decarbonise your home. So as I said, it's greener than a green tariff and cheaper than rooftop solar. For a pretty modest upfront cost, you get real impact, you get stable prices for the long term. It's super, super simple. It's really flexible. So it doesn't matter, you know, unlike rooftop solar, you don't have to live in a house with a lovely southwest facing roof. You can rent your home. It's just, and also if you move, it's fully portable. So you just phone up your supplier and say, I've moved home, and you get the savings from your wind farm applied to your new home. So yeah, we've got our first wind farm, Great Valley, is open at the moment. So do please have a look at that, and yeah, you can join today. So and I think that's the end of the presentations there.
Thanks, Mark, Sarah. And yes, I must declare I am an investor in Ripple Energy, so I do declare an interest in that respect, as well as you've already gathered that I'm involved in terms of being a consumer as far as Octopus Energy is concerned as well.